Okay. Can you see my screen now? Okay, yeah. So can you just okay, can anybody see my screen? Just react if you don't want to talk, so I
I can
can
see
know
your
you. All right, great, 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 great. So yeah, so like I was saying before this session ended, like I was a backend developer. My stack was Java, right? Java and Spring Boot, you get. So and then in September of last year, I made the transition into Web3 security. So I am a Web3 security auditor. So we audit smart contracts. You get. By the way, after we deploy this smart contracts, I'm going to like explain, the roadmap to becoming a security researcher, right? So yeah, so like I was saying, right? So we have what we call events, right? So events is a way to like, I mean, so just like console.log of JavaScript, and I've forgotten the one for Java. It's been a while. So, but it's just a way to like show people, or it could be people, or you could just like show what is happening or print it out, basically. So in this case, we used to log events actually, right? So we're going to log two events in this smart contract, which is deposits or deposited, which is going to be logged when people deposit, tokens or Ethereum into our contract. So it's going to take in the address of the person sending Ethereum, which will be the sender, right? Because anybody interacting with our contract is interacting with an address. So that's why we take note of the address, right? So that is why, like we said during our class, Web3 gives you this sort of anonymity. You get like all you have to do is to just create your wallet address and interact with smart contracts. So we're going to create this event, and it's going to take into things the sender's address, and then we're going to take in the amount that's been deposited into our contracts, right? Amount. So the next one, okay, we're ending into it with this, right? So we can see that I mean, in this is what I'm doing is I'm declaring variables. They call it variables, right? So after each declaration of a variable, you have to end it with this semicolon, yeah, semicolon sign. Just like how you end your sentences with full stop in English, in normal English. So in Solidity and even Java and JavaScript, you end it with semicolon. So we have two types of events. We have we're going to, you know, declare two types of events. Deposited, which is going to be an event that will be emitted when someone deposits, and then we also have withdrawn, which will also be an event that will be emitted when someone withdraw. So withdrawn, right? So this was taking the address, just like deposited, right? Address of the recipient in this sense, which is like the person receiving the um the token recipient, and what's the next thing again? Okay, the amount, right? The amount the person is receiving. So 5, 6 amount. So yeah, so the last thing we want to do, okay, before we start writing our functions, there are two more things. We want to create a modifier, right? So this is very, very important. Um, Modifier. So what is a modifier? Basically, it's more like a function that basically sets certain conditions. Like in this sense now, in this place, because we're dealing with money, you want the place on the mainnet now, we're dealing with money. So we need to be careful of the kind of things that we let users do, right? So modifiers is one of the ways to sort of like set access control, basically. Um, just like in web development, access control. Oh, okay, we have the host. The host would have certain privileges, and the users will be able to log in and use the platform, but they cannot delete other users off the platform, for instance. Right. So modifier is one of a way we can just sort of do a quick check and then continue coding, basically. So in this, how do we do it? So we name just like this is very readable. You can see the contract file set. This is basically saying that this file sets, this code we're writing is a contract, is a smart contract, right? Named file set. And here we can see where we declared the owner address, we declared the variable and stuff like that. So we also declared the event. So now we're declaring a modifier, right? So we're going to name it only owner. So what this will check is going to check if the address that is calling a particular function is the owner of this, what's it called, this smart contract. If it's not, it's going to throw an error, right? So this is how we do it, right? So by the way, we're going to write modifier, right? Because it's going to be a modifier. It's going to come. Modifier actually, most times they're triggered before a function call, right? So we're going to see how. So we're going to, but it needs to have a name. In this sense, we're giving only owner, right? Which is very descriptive enough. You know that, it's only owner that can call this particular thing. So for every function, it would have these two, braces in front, you get. So these are you know a function, you get. So unlike variables, you can see that variables do not have this something like this. You get, if I do this, it's going to throw an error, right? So this is a function, so it needs to have those things in front. And then the things inside these braces now are what we call parameters, right? So this sender and amount, the parameters of this, deposited events, for instance. So our only owner modifier would not take in any parameter. Rather, it's going to take in, we're going to write, what the modifier should do. So it's going to check. So what it's going to do is that, okay, let me write this. Let me write a comment. So it will check if message or sender is the owner. I'm coming. Okay. So it's to check if the message sender is the owner, right? So I'm coming. Okay, let me just write this, probably complaining that we have not, written code inside it yet. So let me just write something, right? So we're going to make it, check. So we can do it in two ways. We can use if statement, or we can also use require, right? So we can say it requires that the message to sender, if that's the person sending in a transaction or making a call to this function, or to the function that we're going to be implementing it on, is equal to the owner. And you can see that we have declared the owner here, right, as an address. So that's what we're calling it. So we do not have to write, address public owner in front of it again, because it's already a variable that, is stored in storage, right? So we're calling the person calling this function, and we're using so this message center returns the address of the caller, and then we're checking it against the address of the owner that we've declared here. So if it matches, it will not do anything. It would rather, sorry, if it matches, it's going to do this. What this means is that, okay, I'm coming. Not that, yeah, this. So what this means is that I'm coming. This is probably complaining that I've not put a semicolon at the end here. So what is it saying is that if this is if this, okay, this modifier now is literally saying that if the person calling this function is the sender, or is the owner, right? It should continue with the code that is going to be in the function, which is this, right? So I'm going to show you how this works very soon, right? But when it makes a call to this and then it checks if the person is the owner. So if the person is not the owner, I want to throw an error message, right? So require allows us to do that. All after this, you just create a comma and then set our error message and say only the owner, something very descriptive, sure. Only the owner can perform this transaction, or maybe can perform this action. Only the owner, yeah, owner can do this. Do this is not really, specific enough, so we can say can call this function to make it much more specific, right? So our modifier is done, right? So what this does, it checks if the person calling our function or the function that's going to be implemented on. By the way, modifiers are implemented on functions, which we're going to see, right? Which we're going to do. So it checks the person making the call to that function that is implemented on. If the person is the owner, it continues with the code that's going to be in that function. If the person is not the owner, it reverts, like it stops the process and throw an error and say, okay, only the owner can call this function, right? So yeah, so let's continue. So that's with our modifier. So every contract must have a constructor, and our constructor is a way we set, we set what they call it though, default parameters. So yeah, now I've been saying, okay, in something like this now, we've been saying owner, but we have not set the owner to any address, right? So by default, we want to set the owner inside the constructor, right? Because we need to set the owner for us to be able to check or perform the check against the message sender, right? So how do we do this? We declare parameters or initial parameters in the constructors, right? So what we're going to do is that we're going to say owner, which is this public variable I've declared here, is equal to message.sender. So what this means is that every contract, even in except it's an abstract contract, right? So an abstract contract is a contract that does not take in function. You get? I mean, it takes in function, but you don't have to implement the function rather. So because this is a contract, this is a smart contract, and we need to implement our function, right? We need to set in a constructor. So every contract is a contract because we can see here is written as a contract. Every contract must have a constructor, and the constructor is the place that we define initial parameters. And this constructor now, nobody calls constructor. Like every other function, nobody calls constructor. Constructor is only called once, and that's when, I mean, in the context of this smart contract, in Solidity rather, constructor is only called once, and that's when, this smart contract is being deployed, right? So what this does is that it checks the person deploying this smart contract, which we're going to do, and it's going to be my address, right? So message sender means the address that is calling a function, right? Because back to our transaction, right? I mean, our talks on transaction, because the blockchain stores record of transactions, right? So when you make a call on to a smart contract, you're literally sending a message, like you're sending a transaction, but inside of that transaction, there's a message, right? It could be like the value you're sending, like here now, for instance, where is that this thing? Like in that, fastest we interacted with, the value that were sent was 0.005, you get. So that's the transaction we performed, right? And in that transaction, that messages, you can have, it stores the record of, the sender, the records of the value as well. You get, if there is no value, it sets it to 0 by default, right? So what this is literally doing is that is setting the owner to the person that is calling this function, this constructor function on deployment, which is going to be my own address because I'm using my address to deploy this, right? So, do we sort of like, are we following? Do we like understand up to this stage?
Yeah, well, so
All right, good. So now we're now entering like the main thing here. So all we have done is to just declare, the public variables and then the constructor. Now, the main logic, the main business logic, what do we want our faucet to do? What do we want this to do? Is to be able to deposit and I mean, for people to like deposit Ethereum or Sepolia Ethereum and then withdraw Sepolia Ethereum, you get. So now let's create a function, right? So for us to create a function, we would need to write function, right? So function to indicate that this is a function. So yeah, now, what's it called? Okay, sorry. By the way, we forgot to add something, right? So because it's a file set, and that file set now, what I did at the beginning, I requested fonts from that Google file set. You could see, right? So we need to write request font, right? So request font so that we'll not forget, so that we can implement that function that will undo that. So basically, what our faucet is doing is that it does three things. It allows users to request funds, just that they can only request funds once a day. That's why we have this cooldown time. And then the amount they can withdraw is 0.001 Ethereum or Sepolia Ether, right? So these things will be included in our request fund function, right? So basically, our faucet is doing three things: allows users to request funds, allow users to withdraw, right? And allows users to deposit. So let's just continue, right? Um, so this is just creating a map, a mental map for us to know what we want to do. You guess that will not forget or will not leave out a function. So let's continue, right? So I was saying that, for us to create a function, write function, and then the name of the function, which will be deposits, because we're creating deposit function first. You get deposit, yeah, deposit Sepolia Ethereum. So we're creating that first. So we need to make it call it public, right? So we can tell it as external, meaning that users, anybody on the blockchain can call it external, and then payable because it's going to deal with uh, token, or it's going to do with money, like you have to transfer token. It's going to be payable, right? So, so you can see in front, is saying gas, right? You know that when we went over, in our last class, when we went over transactions and gas, we discovered that any transaction we're performing on the blockchain is going to come at a cost, which is going to be a gas fee, right? And the gas fee is going to be paid by the person calling that function, right? And if you could remember, what I did that last time, I transferred Sepolia Ethereum to another address, and I was deposited. I mean, sorry, I was not deposited. What's the word? I was deducted rather, right? So I was deducted gas fee and also the amount that I sent to the address. You get, so the person that initiates calls in the blockchain or in smart contracts will be the one to pay for the gas fee. So you can see anybody calling this what's it called? Anybody calling this constructor function, which is going to be me, I would have to pay, this unit of gas you get, which will be converted into Sepolia Ethereum, which is going to be a very small fraction you get. So just like, all those, I mean, you can see, it's just know that gas is charged not only when you even perform transactions, but even when you call a smart contract, you're going to have to pay a gas fee because that's how it is. You get. So so yeah, as I was saying, so this is going to be a deposit function, and we said it's external. It's callable by anybody on the blockchain, and is payable. It's sensing money. You get, it deals with money. So what are we going to do now? Our deposit here. So because people are going to be calling this, we need to check something. We need to check that. Okay, so how do we check? We can write if statement, but require is very much faster. So we'll just write require and then set the condition and then the error message you get. So what's the condition? It's going to require that the message dot value, which is a which is determined from the person that is calling this function, like the value person is passing, must be greater than zero. This greater than sign, yeah, greater than zero. If not, we say we'll say something that is descriptive, like the error message is true. Can't, no, something that is, what can I think of? Amount must be greater than zero. So yeah, what this is doing is that just like this here, where this one is checking for the message sender if it's equals to the owner, this one is checking if the message, you can see that is calling message. Message is actually a global variable, is known on the blockchain. You get, so we don't have to declare who message your sender is. We don't have to write it here and declare it, just like our declaring function. I mean, our declaring the owner here, we don't have to do that because message sender is something that is global. You know that the blockchain itself knows, right? What it means that is the person that is calling or making the function call to that particular function. You get, so in this sense, in this one, it's gonna be my address because by default, I'm the one that is going to call the constructor. by default because the constructor is only called once. But yeah, this is a function. This is available to anybody. You can see that's why it has external in front. Anybody can call it uh, any amount of time, right? What are we doing? Okay, sorry. So so anywhere you see a red line like this here, it's literally saying that there's a problem, and that's because we did not include our. I mean, it's supposed to be inside the braces, inside these braces, right? So yeah, so the red line has gone away. This is just saying greater than, less than. You get, if I was using VS Code, I can change the color of this so that it's not returning red, so that it's not confuse us. But anyway, you see red, it means that there's a problem. You get, so this is, but by default, the color of greater than is red here, so there's no problem. So our require function, I mean, our deposit function requires that the value we're sending must be greater than 0. And if it is, what's it called? It's sensing, the stipulated term into this contract. You get, so that's basically what it's doing, right? So we're going to emit an event. So what event are we going to emit? This deposited event you get. So we're going to say emit just like console.log in JavaScript. So emit deposited. You can see it's going to be, yeah, so it's because I've declared it already. So it's taken in the you can see what we declared, the sender and amount. But now we have to explicitly write it, right? So now the sender would be okay, I'm coming. The sender is going to be the message, the sender. That's the person calling this, and then the amount is going to be the message dot value. So these are global variables, right? So this is just saying that okay, store the amount that the person is passing, that the person calling this transaction is passing, and store the person's address as well. So yeah, I mean, this is it for our deposit function, right? So this will deposit Ethereum, separately Ethereum into our smart contract. So the next thing that we're going to okay, I think what I should have done, but then let us continue. But what I should have done is to just list out the function we're going to be creating, I mean in codes. So yeah, let me just do that next. So we're going to be creating another function named requests funds. So this is going to be the function that will process the funds that we're requesting, right? So we'll just implement this, right? And then we'll set another function, which should be to function to, because the withdrawal amount is something that we would maybe in future might want to change it, you get. So we'd have to write a function to set withdrawal amount, yeah, amount. Oh God, okay. So our semicolon, don't forget that. So the next one is going to be, what again? Let me check here. Okay, cooldown time as well, right? Because we are setting cooldown time, we're setting withdrawal amount, right? So we have to set function to set cooldown time. Cooldown time, just like the amount of time required for you to call this request function again. So we have to set cooldown time. Braces, so it needs, bracket and braces. So braces is going to be where we're going to write our codes in. You can see that the code for this deposit function is inside this deposit, braces, not inside of the bracket. The bracket, okay, this is how like in the bracket, what should be in the bracket is going to be parameters. In this sense, this is parameter here. Like here now, these are parameters, right? Then the code should be inside of the braces, right? So the braces has the beginning braces and ending braces, right? And we have quotes inside. So this is saying that all the quotes inside here has to do with this deposit function, right? So every function would have their own implementation. You get, so because contracts, like we're writing all this inside this particular smart contract named contracts and name them faucets, right? So you can see that all the codes that we're writing is inside this faucet braces. This is the opening brace and this is the ending brace. You can see that they're indicated as yellow. So all the codes we're writing, right, belongs to these contracts, this facet contract, and each of them, and this facet contract, it has different functions, right? So those functions now they have what they do as well. So it's just like the normal human being, and then like in the last I was explaining that smart contracts are like human beings, for instance, where we our body as a whole, we are like the human being, and then we have eyes. So our eyes, now picture your eyes as they function. So what does your eye do? Maybe the person, I mean, God who created us probably coded and say our eyes should be able to see things, right? So that's like a characteristic. You get a function. Our hands use like we put those around to like move things and interact with each other with our mouth as well. So when you declare functions, you have to write in implementations. So implementations are what gives it its more unique characteristics. You get That's why smart contracts is basically a set of code, right? Executable code or self-executed code that do certain things when certain conditions are met, like in the explanation I gave. For instance, now in this deposit function, what does it do? It deposits circular Ethereum into this contract when a condition is met. And what's that condition? That the value that we're sending must be greater than zero. You get So now anybody on the blockchain cannot say, okay, I deposited into this smart contract and and it did not reflect or something. We can just go and check. We just copy the transaction hash. Since everything on the blockchain is public, we just copy the transaction hash and check if the transaction was successful, like we did in our last class. You get So let's just continue. So now we have, you know, okay, by default, we need to have a receive function. So this receive function is going to be, you can see that it was even auto-completed by itself. So this receive function is very important. It's going to be the function that will enable us to receive tokens, receive Ethereum. So any smart contract at all that you want to develop that needs to interact with tokens, it must have this receive function by default. If not, it will not be able to receive tokens, right? So inside of this receive function, we don't need to even implement anything, you get. But yeah, we just have to implement, maybe due to our own choices, we want to be able to like emit that, okay, somebody have deposited, just like how we have in this deposit function. So what I just copy this, well, because of time, just copy and paste here. So copy and paste. Yeah. So what this is doing is that it's emitting an event that, okay, it's telling like, you know, okay, let me show you guys something. Can you see my screen? Like, okay, this is a contract address, right? So this is like after we deploy this smart contracts here, we're going to come and view it here. So you can see that on this place now, this was a contract address I deployed earlier today. So you can see that it's going to have a section for transactions, contracts, and events. Contract is like a smart contract. This is like, you see all these things we're writing here now, but in human readable words. This is what the virtual machine converted it into bytecode so that the virtual machine can understand. You get So those words we're writing, those contracts, blah 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 blah, they actually converted into this bytecode so that the virtual machine can understand. So now, all these events that we're declaring now, but we're able to see them here in this thing event. So events are actually public. You get So that said, let's continue. So when we're emitting this deposited function, it's going to show in this events place, like when we deploy the smart contract. You get So I don't understand them. Like any questions so far?
Sorry, can I ask a question?
Okay, sure, please. Yeah.
So, I wanted to ask about, although I didn't start from the beginning of this class, I just joined today, but I think I've understand some few things. So the question is, at what point does this token, is it generated?
Okay. At what point is it what? Generated, right?
Token,
So
yes, generated. Is it when the transaction happens? That's when the token is generated.
yes, 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 you're correct. So, like for instance, now in this sense, right? So, if we're creating a big scale project, yeah, with there's something called minting, right? So we can literally just declare a mint function that mints token. That's like anytime we call it, it's going to have a total supply. That's like the total amount of tokens that can be minted. You get. So anytime we call the mint function, it's going to mint money. Just like how, I mean, it's going to mint that particular token, that project token. You get. Just like how, CBN mints Naira, for instance. Yeah. So we could want to, because we are using Ethereum, we have to maybe want to have an ERC20 token, right? So we'll declare the mint function that would create that token you get, and then it's going to have a total supply, which is like the total amount of tokens that can exist. So when in the process of minting, when that total supply is exceeded or is met, it's going to prevent, further minting so that it will not exceed the total supply. So now, because yeah, we're going to be dealing with sepolar Ethereum, which is like a global, just like Ethereum, but now and a test Ethereum. So all we have to do is to just, create a file set, and then we're going to, when we're deploying, because this create an interface for us to deploy. When we're deploying, we're going to use MetaMask to deploy, and I'm going to indicate that we're deploying this on sepolar Ethereum network. And anything that's going to happen on that sepolar Ethereum network has to use the native token, which is going to be sepolar Ethereum. And that's what is in my wallet here. And like you saw that we got it from this site here, Google Cloud, this link basically. So like, I mean, like, does that answer your question?
Yes, yes. So it's more like let me get it straight. It's more like when somebody logs in, you pay the token for the person, right?
When
Then
somebody,
till
yeah, 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 yeah. You have to just
kind of
that,
scenario.
what did you say? Sorry.
I said it's that kind of scenario now till when the token expires, then it logs out, right? So it
Yes,
generates
yes.
and creates the token. Are we cool? Is that
Yes,
what you mean?
okay, in this context now, in this context, this sepolia Ethereum is actually, you know, a token that is deployed on a live blockchain, which is sepolia Ethereum blockchain. You get. So now
Mm,
this site we're interacting with, right? Underneath it is a smart contract that already have sepolia Ethereum in it already, right? So now, when we're requesting, all we have to do is to come here and request for Sepolia Ethereum. So because we need Sepolia Ethereum to build on Sepolia network, which is literally what we're doing, you get, because we have to pay gas fee, we need to, have tokens to interact with as well on the blockchain, you get. So this is going to send us Sepolia Ethereum, you get, that is minted on the Sepolia Ethereum blockchain. You get, just like, for instance, if you're using if you're deploying this on mainnet, which would be Ethereum, right? You would need to have Ethereum. Probably you can use, what some people do is to get it from Binance, or probably from some decentralized exchange, or centralized exchanges like Binance, where you're going to, like, probably first of all convert your Naira into your cryptocurrency that you get on Binance, and then send to your wallet, and then use to um, perform, interactions in your smart contracts.
okay.
Yeah. So yeah, nice questions, by the way. Very, very good questions. So, but is it clear now?
Yeah, it's clear. Yeah. Okay.
All right, great, great. Okay, so let's continue. So yeah, so the next thing we're gonna do is to what was it called? You know that, you know
Sorry,
that,
can I ask? Sorry, can I
okay,
ask a
sure,
question?
sure,
Yeah.
sure.
So instead of using this ID, this remix ID,
Mm,
and want to use a VS code, uh,
mm, yeah,
what 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 should I do? Because if I'm using it, it's network based, and sometimes it might be hanging or something. Because I'm doing the same thing as you're doing now. So what
yeah.
what should I do? What should I do?
Okay, so Remix now, like, it's sort of abstract so many things for us, right? So it's more like beginner friendly. That's why I'm using it. So if you want to do this on your VS Code, right? You need to what's it called? You need to know how to use Foundry, which is like okay, when I was using Java, is like Maven, you get. So it's a place where you can
Yeah.
like test, you get. So it's like Maven in Java. I don't know of JavaScript because I never wrote JavaScript. But in Solidity, we can use Foundry. We can also use ADAT, you get. So we have to like configure the test environment, right? So you can actually head over to okay, I wanted to do this at the end of this deployment, but you can just come to, where is that platform again? Siphon Updraft. Yeah, Saffron Updraft. Just type it on Google and then click on it's more like a platform where you learn, blockchain development, you learn, what's it called? How to this smart contract as well. This is the guy teaching, Patrick Collins, very great teacher. So explore all courses. So when we do this, we would be able to see, you can see now blockchain. By the way, I recommend anybody that's interested in this should actually take this. Just it's free actually. It's not like Udemy, it's free. I don't even know why it's free. It's not supposed to be free, but it's free then. So you can take this blockchain basics course, which is literally what we did. Then Solidity 101, which is, I mean, when you take this, you understand what we are. I mean, for those that do not have, development background, they will understand what we're doing here with Solidity. And then, yeah, so what you're asking is, how we could replicate what I'm doing on Sepolia. So before we would need to use Foundry, which is just like Maven, you get. So we have to use Foundry. So you can just come and check out Foundry fundamentals, which is going to show us how to like test our project, you get, and also deploy it on, and how to deploy our smart contract on Sepolia Ethereum, for instance. I think in one of the examples they used Sepolia Ethereum to explain as well. So I would advise that you check out this Foundry fundamentals to see. So it's actually a 10 hours course here. So this is what I'm doing actually. I'm a smart contract security auditor, right? So you can see that this is much more advanced, right? It has some prerequisites which you have to go through this this course, basics, the blockchain basics, Solidity 101, Foundry fundamentals, right? So you also have to go through advanced Foundry, and then you're able to learn how to audit smart contracts, right? So what's it called? So yeah, so when you do this, I mean, I'm saying this for everyone, right? So since we're already coming, let's just continue and then go back to deploy. But when you do this finish here, you can, if you want to become a blockchain developer, right? You can take this, right? You take blockchain basics, Solidity, Foundry. You can stop at advanced Foundry, right? But if you want to become a smart contract security auditor, you have to take this course. It's very important. You get. So what is smart contract security auditing is like we're basically auditing codes, right? That blockchain developers wrote or projects wrote. So we're auditing this to spot vulnerabilities in those codes, right? So that's what we do. And you have to. I mean, this is gonna give everybody like, more like an idea of what to do. You get. But then it doesn't mean that when you go through this course, like you should be able to understand how to read code and how to audit code. But I mean, you have to make more research and you say about, security vulnerabilities in smart contract as well, right? So some sites you can check that out is rescue.io, which is one of the, blogs. It's a blog actually. I recommend a lot. So I think this is live coded. So I mean, this is going to be on YouTube. So that's why, I mean, I did not write any, what's that thing called though? Okay, this will end in 1 minute's time. Please, when it ends, let's rejoin. I think that should be the last session, so we'll be able to deploy our contract. So I did not write any, what's this thing called? This Google document stuff. I've forgotten the name. It's something like this PowerPoint now.